Okay, so today we are going to talk about a very important subject, which is the binary and hexadecimal representation in packet trace. Okay, so in general, when we want to make an address for any device, so for example, if we have a specific device, let me pick a device. Okay, and also we have the switch that connect all the devices together. So we have another PC, which is this PC, and we want to connect this network together just by using the straight through cable. Okay. And now if we want to make the network work, so we can press on this button to make it faster. And now, if we want to check the connectivity between this PC and this PC, we will have no connection between the PCs because the PC5 has no functional ports. Why there is no functional ports? Because we didn't have an address for the devices. So we go to the desktop, and for the IP configuration, we are going to put the IP address. The IP address representation here is in the decimal notification. Decimal notification means like the numbers we are using daily. For example, the 10, 12, 13, 14, 22, 120, all these are decimal numbers. Okay, this is decimal notation. The IP version 4 is in decimal notation, but actually the computers deal with the binary notation. Okay, so let's see what is the decimal notation and what is the binary notation. Look at this IP address. The computer sees every IP address for each computer like the IP address at the top. Okay, and the IP address contains four different colors here, the four different octets. This is the first octet. Okay, let me find a mark like this mark. This is the first octet, this is the second octet, this is the third octet, and this is the last octet or the fourth octet. Octet means eight binary numbers. Okay, but actually we are not going to put this into the packet tracer immediate. We have to convert it to binary equivalent. How to convert to binary equivalent? This is the subject of the material in the PowerPoint in the classroom. But actually, we don't need the manual way which we studied in the classroom. We can find a faster way. Okay, so let's use the calculator. Let me find the calculator for you and put it in the middle of the screen like this. And if you have your calculator at the standard view, change it to the programmer view. Okay, and then you can see we have here. Okay, I think oh, sorry. Okay, I have to move to the top because this is for the programmer view. Okay, this is programmer view. Okay, this is programmer view. And if you click binary here, you can find only two numbers are activated. Sorry, I have to move this little bit. It is not moving. Okay, now I can move it. Okay. Okay, just to make it inside the screen and fix the screen here so it appears. Okay, now we can write down this number here, the 1, 1, 0, 0, 0, 0, 0, 0. And this is the same number, the same octet here. Okay, and of course, as you see here, this is the representation in binary, and the equivalent decimal is here, 192. So immediately we can write down here 100. Okay, 192. 29? 29. Sorry, 129. Okay, 120. 92. Sorry, 92. Okay, so this confusion. And for the second one, we can also write down, we can clear and then write down the second octet here, the same, but using the same way. So write down 1, 0, 1, 0, 1, 0, and we have the last 0, 0. Okay, this is equivalent to 168. So write down 168. 168. And this is easy. This is 1, and this is 1. Okay. And the subnet mask is very important because the subnet mask define what is the network address. Because we know this part here, we have ones, all ones. All ones mean if you convert it in binary like this, just to clear and put 8 ones, this is 255. So this is 255, and this also 255, and this is also 255, and the last octet is 0. So this is the subnet mask. The subnet mask is important because it defines the network. So here we have the 192.168.1 is the network address. This is, we call it network address. Okay. And let me close this phone. Okay. And this is the network address. We call it network address. Network address. And this is the second part is the host address, host, or the host part. Okay. So the computer can define which part is the network part, which part is the host part. For example, here we have network IDs 192.168.1.0. This is the network address. And we have the host number 1. So this is the host number 1 is the first address in the address space. The host number 1 is usually we put it to the default gateway. Okay, we understand now how to convert this IP address into the IP address into from a binary to decimal. And we understand now how to convert also the 255, the subnet mask, and why we have a subnet mask. The subnet mask is important to define the portion of the network and the host portion. Okay, so return back to the packet tracer and continue with putting the 192.168.1.1. This is a default gateway. We don't use the default gateway. Actually, we use the 11 or whatever number because we have this octet. The entire octet can be any number starting from 1 to 255, but we will not put the 255 and 1 because 1 is reserved for the network address and 255 is reserved for the broadcast address. If the computer want to broadcast a message, it sends to 255. So, and this is the subnet mask. By default, it detects the subnet mask because this is, we call it class C. So in class C, it's 255.255.255.0, okay? So here we have the IP address and the subnet mask is set, and we can put the IP address here, the IP address here, 168.1.12 with the same subnet mask. So they are in the same subnet or the same network. So now if we test the connectivity between these two devices, is going to work as you see here. Okay, so this is the first part. Okay, let us try to add more devices. Let's try to add more devices. We have here 4 different devices, and let these are in the same network, and we are going to put something else. Okay, and we put something else here. Let's connect these devices to the switch and pass forward. And if we try to connect this device to that device, it's not going to work. Why? Why? Because there is no IP address for this device. So we have to put an IP address for this device. We have to put another IP address for this device. I prefer to have the same IP address range because we want all of this network to be together, to be working together. Okay, let's try 192.168.1.13. You can say we can start by 20, okay, here. Whatever is working, no problem. But this is 20 and this is 21. Let's put it as 21. So 192.168.1.21. Okay? And let's test the connectivity between the devices now. This device and this device and is working. This device and that device is successful. This device and that device, sorry, this device and that device. Okay, let's delete this. This device and that device working. This device and that device working. This device and that device, everything is working because they are in the same network and they have assignment for different for the same subnet or the same network. Okay, they are in the same network. Okay, let's play with the subnet mask a little bit. For example, we go to the PC, the first PC to the top, and instead of having this one, we put it as 2. Okay, and also this one we put, instead of having the network portion to be 1, we put it as 2, and see what's the result. Okay, so make sure that it's fast forward and then try to test the connectivity between these two devices. Okay, they are successful, but the connectivity by that device and that device is not going to be successful because this is in network address. We can put a note here. Let's put a note here. This is 192.168.2.0. This is the network address of this subnet. And we have also here this 192.168.2.0, and this is the same subnet, but these are not in the same subnet. They are 192.168.1.0. This is a totally different IP network address. 192.168.1.0. So they are here. We can see that we have this device and that device in the same network, but this device and that device, they are not, they are in a totally different network. So if we test the connectivity between these devices, it's going to work. But if we change from this device to that device, they are not in the same network and the connectivity is failed, as you see here. Okay? Okay, so we understand the importance of network address. But now let's return back. Sorry, let's return back to the IP address we are used to, which is network number 1. So everything is network number 1. Okay, everything is network number 1. Return to everything is network. So the connectivity is going to work for, because they are all in the network address. Sorry, just I want to make sure that I'm deleting the correct place. All the network, they are in this range. Okay. But now we want to play with the subnet mask. Okay, so let's play with the subnet mask here. So instead of having this, we put 0. So this subnet mask is totally different. And here we have a different subnet mask. And here we have, this is, okay, so write down that this is 255.255.2.0.0. And here to the bottom, we have 255.255.255.0. Okay, so these two devices are from different subnet, and sorry, not from from different subnet and using a different subnet mask, and this also from the same subnet, which is this one. So these two having this subnet mask, and these two having a different subnet mask, but as you see here, they are in the same network. Okay, so let's check the connectivity between these devices. Oh, it's successful. Even the different subnet mask. Let's try again. Oh, successful. Let's try internally. Yeah, successful. So everything is successful. Even we have a different subnet mask. Why is that? Because this is bigger network. We can say the sometimes they write it as like backslash backslash 16. Okay, 16 means this is 8 and 8, so it's 16. And is this also they write it as backslash 24. Sorry, 24. So 24 because 8 multiplied by 3 is 24. So this is a 24. But here the 24 is a subnet of the 16, so it's going to work because they are in the same subnet. The they are in the same subnet means the 24 is part of the 16. The 16 is bigger and it contains the 24. That's why they are working. Okay? That's why they are working. Okay, so now we move to a different point, which is subnetting. Okay, let's do the subnetting part. So remove all of this. Remove that one. Remove that one. Remove that one. Okay, and let's return it back to the paint. I want to make a subnet out of this, two subnets out of this IP address range. If I have been given this IP address range, how to change it to two subnets? Okay, so to do that, we select these two. You can select how many subnets you need. You need 4 subnets, so I selected 2 bits, or 2 subnets, 1 bit, 1 bit only. So this is 0 and this is 1. Because this is network, I'm going to add more bits here for the subnets. So if I need 2 subnets, I put 1 bit. If I need 4, so I add 2 bits. If I need 2 to the power n, which n is the number of bits that I'm going to borrow. So this is 8 subnets, this is 16 subnets, and so forth. Actually, for simplicity, we will work with only 4 subnets. Okay, so we are going to borrow this portion, network portion. Okay, and also in this we can have any address starting from 0, any numbers from 0 to from 0 to 2, which is you can put this part can be either 0 0 1 0 1 0 1 1. Any network out of these 4 networks. We need only 2 networks, so select randomly whatever you want. Let's select, to make it more challenging, let's select the last 2. Okay, so the first subnet is going to be what? Is going to be uh the first subnet is going to be 255 255 255 dot. The first one is 10, and if I put 10 here, this means this is the last octet, which is 128. Because this is 1 and 000 is similar. Yeah, it's 100. If you put in the calculator 1000000 is going to put or to give you 128. So this is the first subnet, which is 128. What about the second subnet? The second subnet is similar to this one, which is 11000, which is 192. So the second subnet is going to be 1255. This is the subnet mask. We didn't talk about the IP address so far. So 255.192. Okay. So these are the subnet masks. And for the network address, is going to give any addresses, but make sure this is 0. So this is the network. Let me clean something here. Let me clean this part. Okay. Okay. Okay, let me clear this part, move this part away. Okay. Okay. So this is the network address is going to be 192.168.1.0. But make sure that you put double X here, XX, and 0, 0, 0, 0, 0. Okay? These are the first and the second. So, and the second one is 192.168.8.1. This is no dot one dot XX and all these numbers. Okay? Okay, so this is the first network and this is the second network. And just give me a second to revise something. There's a small mistake here. Let's correct it by using this color. This is the subnet mask is going to be fixed. The subnet mask is going to be 255. Why is not changed? Okay, let's correct it by the black color. So 255 to 255 to 255, because I have taken 2 bits here. Okay, I have taken 2 bits here, so this is going to be fixed. It's going to be 11, which is 192. Okay, 192. And this is going to be fixed for both networks. So remove this and put 192. Okay, so I put here 192 and also here the same thing. The first network and the second network, they have the same subnet mask. And it means, as we said, they have the subnet mask, but different network. So the communication will not work. We will test it here, okay? And now this 192. And for the network address, we have 192.168.1. The first one is 11. We selected the last two, which is the last two 10 and 11. So if this is 10, this means if it is 10, this means it's 128. And for the second IP address is 192.168.1.192. This is the second network address. This is the second network, and they pay attention because if you try to make a host inside this network, it's going to be challenging, because if this is the last one, you have to add whatever you have for after the 192. So for example, this one is 1. This means 1 plus not 192. So the beginning address or the first address you are going to give is 129. Okay? It's very important to understand this because this is 10. So whatever you put here, these are the numbers of the hosts. So for example, if you put 01, this is 2. 2 plus 192 is this is 130. So one host is going to be 130. But if you put 0 here, or for example 4 or 5 or 6, any number less than 128 is not going to be accepted, because simply because this is the start address. This is the start address. Okay, let's see this in practical. We understand the two subnets, and we know the network address for each one of them and the subnet mask for each one of them. This is the first network and this is the second network, and we said we have mistake here, so remove all of this. We already corrected them. There is no need to remove. It's correct. Okay, we have only this error because the subnet mask is going to be the same in the two different networks. Return to the network, and to make it simple, we can say this is the first subnet, subnet 1, and this is the second subnet, which is subnet 2. Okay. Okay, so go to the first device and put the 192.168.1.128. Okay, and the subnet mask is going to be 255.255.255.192. Okay, this is the first subnet, 192.168.1. Oh, sorry, this is not the host address. It should be after 128. So we select 130, for example, 130. Okay, and the subnet mask is going to be 192. Okay. Okay, it's correct. So I selected different because the network address is one. This is the network address. I cannot put the network address here. This is a network address. I cannot put a network address here. So now this is IP address of a host. Okay, let's select something else here. This 192.168.1.133. And for the subnet mask, make it 255.255.255.192. Okay, so they are the same network but two different IP addresses. For the second subnet, we put 192.168.1. The second range is 192. So I start from 200s to be safe. So I start by 200s. Okay, it says this IP address is not correct. So 192.168.1.200s. Okay, and here the subnet mask is going to be the same, which is 192. Okay, and now go to the second device in the subnet, which is 192.168.1.201. And the subnet mask should be the same, but 192. Okay? Okay, the last thing here is to test if the connectivity is working between the same subnet or not. So test that and that, successful. Test that and that, not successful, of course, because they are different subnet mask, they are different subnet. That and that, successful. That and that, not successful. Okay? So we understand now because these are on the same subnet, they having the same network address, and all these two on the same network address. Okay, so here if we want to connect these two subnets together, we can connect these subnets together, but we need a router. We need to add a router in the middle. So I think I can show you quickly how to do that. Okay, let's do it. Let's do it because now we understand the subnets and we need to connect these two subnets together. So remove this device, okay, and add one one device here for this subnet, and one device here for that subnet, and add a router in the middle. Add a router in the middle, okay? Okay, okay, let's do that. Okay, so connect these two devices to the same. Okay, and these two devices to the same switch. Connect that device to the router, that device to the router, and that's it. Now we can configure our network. Okay, let's make it like this to see it, or move all these together So we can see all the arrows here. Okay, so this the first subnet, this is the second subnet. We see now that we have all the connectivity. Make sure that is not removed or change it. Okay. And now we need to understand that we need to put the default gateway. So for this one, we have the default gateway should be one after the 128. This is the 128. The 128 plus 1 is 130. So the default gateway should be 130. So we go to this device, test the gate here. This is 0, 1. So go to the 0, 1 here and put the default gateway is 192.168.1.130. Okay, why it is 130? Okay, let's go back to the paint and see why it is 130. Okay, so here we have 128. So if I put, let's select a different color. If I put 1 here, this is 1. This one, the value of this one is 128. And this is the first one here. We have 1 here as the same here. So 128 plus 1 is equal to 130. Because I said the first address of this range is going to be assigned to the default gateway. The first address is 1, so it is 130. Okay, so the default gateway is going to be 130. I put it 130 and it's working. But I think I put it in the wrong interface because I need to put it up, not down. So I return back and I change this, copy it, and change, remove, and put it in the 01. And don't forget, this is 192. Okay, I forget it actually in the previous time. Okay, and put for that, we said it is started with it started with 192 plus 1 is 193. So I put 193 as a default gateway. 193 as a default gateway. 192.168.1.193. And here also 191 detect automatically the subnet mask. Okay. So we now have all the default gateway. We go to the devices themselves and put the default gateway for each one of them. I think it's changing now. Why is it changing? Okay. Yeah, I put the default gateway is 192.168.1 dot 1 1 1 92 129 129. Okay, this is the default gateway. And let's see if this is correct or not. Why is 1.3? It's not 1.3. This is not 1.3. It's 1 9 129 129. This is 129. And this to the bottom is 192 plus 1 193. So it is 193. It is 193. Okay. So to the bottom is 193, to the top is 192. Okay, 129, sorry. Okay, so I have to go to each PC and put 129, and here I put 193. This is 193. Yes, 192.168.1.193. Okay, copy this default gateway and put it here. Okay, and return back to this device. I don't know what makes it's cleared 192.168.1.1 after the 128. we can start 133. Okay, and the subnet mask 33. Did I reserve it for a different device? Yeah, 133 is reserved. Okay. Okay, let's select something else. 134, the next address. This 192. And the subnet mask is going to be 192.168.1.129. Okay? Okay. Now we test all the connectivity between the devices. Successful. The same subnet mask successful. And the challenge one was connecting this subnet and that subnet. No, failed. This subnet and that subnet. Successful. Okay, so you can wait for the connectivity. For the first time, it takes time, and for the second time is successful, as you see here. Okay, so now any connectivity between the devices is successful, even with different subnet masks or different subnets. We call this is broadcast domain. This means all the traffic is here separated from the traffic here. That's why we have subnets. Okay. Okay, the last thing to understand is to understand the hexadecimal representation. The hexadecimal representation is totally different from the binary representation. For example, if we want to take one of these numbers and make the corresponding hexadecimal number. Oh, by the way, before moving on, some mistakes happens here. So here in the subnet mask, we have one octet for the subnet mask, specifically for the subnet mask, this subnet mask. For the subnet mask, it should be 1 and zeros after that, 2 ones and zeros after that, 3 ones and zeros after that, and so forth. So the first one is 128. The second one is 192. The third one should be 192 plus this one, which is this 192. This is 32. So plus 32, which is 5, 1, 2, 250. So any number outside of even the remaining number. So you up to the last one is all ones, which is 255. Any number outside of these numbers is not going to work. Any number outside of these numbers, this is not a subnet mask. For example, let me give a 130. So try to change the subnet mask to something like 130. Write 130 here and see what is invalid subnet mask, because subnet mask cannot be like that. It's removed. That's why. Okay, so the subnet mask is not correct. You have to select one of these numbers: 192, 128, 192, 215, and so forth. Just you can try to test that on the calculator. Ones to the left, only one to the left, two ones to the left, three ones to the left, four ones to the left, five ones to the left, six ones to the left, seven ones to the left, and the last one is all ones or eight ones, which is 255. Okay, these numbers are correct subnet mask, and that's important to say it before moving on. Now we want to understand how the hexadecimal is done. So it's divided into two parts. This is 111 and 111. This is equivalent to you know about hexadecimal. We know how to convert this, but we can use also the calculator to tell us 111 and 111 is what in hexadecimal is FF. So is hexadecimal FF. I'm not going to explain how it's calculated because this is the scope of not the scope of the lab, is the scope of the lecture, and in detail we explained in detail how to convert the binary to hexadecimal. Okay, and now we have the last thing is to make application for the hexadecimal numbers on the packet tracer. So To make that, we can select a server, and this server is going to be our web server. So write down the web server here just to make it make sure that this is web for the web, okay? And for the services, HTTP is on, and we need to add new file, and this file is osama.htm, and add a style for having a background color style, okay? And the style background color, okay? And we close the style, as you know, if you know about HTML style. And in the middle, make a body style, and this body style is background color. Background color is equal to ff 0000 and at dash here. Okay. Okay. So no need for the okay. A semicolon. So background color and body and style. Okay. And save the file. This background color is written in hexadecimal, the background red, green, and blue. So the first one is red, the second one is green, and the last two is blue. So let's try this is red. This is going to be give us an HTML with red color. Okay, but before moving in, we have to put an IP address in the same range of the subnet mask on this subnet. So 201, this is one, so we can start with 202. 202 is the IP address of 192.168.1.202. And the subnet mask is 192. And the internet gateway is the default gateway is 192.168.168.1. Sorry. Ooh, yes. Dot one dot 193. 193. This is the default gateway. Okay, this is 193. And we have a file here. Don't forget about this file in the services. We have added a file here. We save this file is osama.htm, and this file we want to open it from different device in different subnets. So we go to this device and try to open the file from the web browser. Takes some time, and we write 192.168.1.202, and we know the IP address, but we don't want the default HTML file. We want our osama.htm. Okay, there is a problem. 192.168.1.2. Is it like that or like this? Why? Let's see the subnet mask. 193. This is correct. Returning back. We have a problem. Actually, we have a problem. Let's see. Let's see this. Okay. And let's see the desktop 192.168.1.202. And this is 192. And this is 193. Okay. I'm missing something. Let me try again. This is 00000193. This is 193. Okay. 193. It's default gateway. Why is it not working? Let me test. the connectivity, sorry, let me test the connectivity between this device and that device. Successful. That device and that device. Okay, this device and that device is also successful. So why it is not opening? Let's open here. I think I opened the right device. It has no IP address. That's why. So this is 192.168.1.202 to the Osama.htm or htm. Sorry. Yeah, so it's red color. Of course, you can play with this. You can go to the server itself and change the color from the services and make it, for example, 00 and make it, I think this is green. Let me see. Save and go to, yes, and go to the device again and green. You see, we are controlling the background by the hexadecimal, the representation. So the hexadecimal representation helps us to, one of the uses is to help us writing the colors. Okay, so here, this is just a simple, this is simple web page. Of course, you can control this web page in totally different thing. Even you can write like HTML and close HTML to the bottom and head and close the head after the body and the body itself and close the body after and put something inside the body. For example, H1 and close the H1. Don't forget, close the H1 because you are going to forget. So hello from Osaka and save it. It's going to ask you to overwrite, yes, and then go to the device here. Sorry, I think, yes, exactly. Okay, open 192.168.1.202, sorry, 02, and here, Osama.htm. There's no hello world. I think there is a problem in my coding. Maybe returning back to that and checking. Maybe this should be HTML. Okay, and save. And now go and open the HTML. 192.168.1.202 backslash Osama.html. Then go. There is nobody. Okay. Can we fix that? We can check again in the HTML. HTML, close HTML. Why we have style? No, body is not in the style. Why I put the style here? Sorry. This is my mistake. So the style should be before the head. This is HTML problem. Is not packet tracer problem. Okay? So return it back again. I don't know why I close it. I should leave it open. Okay, 202, sorry, 192.168.1.202 backslash Osama.html. Go. Yes, it's working. It was a problem because I misplaced the closing tag of this time. Okay, thank you for this lecture, for listening to me this lecture, and I'm looking forward to see you soon, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.